Welcome, everyone. I'm glad you were able to join me. Let's go right ahead. As I mentioned, I'll talk a little bit about how you can build a modern data warehouse. This is going to be a relatively high-level discussion, right? I don't want to describe, how you design your dimensions or how to do foreign keys between your tables or stuff like that. Let's just talk a little bit about the things that you might encounter as you are trying to modernize your data warehouse or even building a new one when you don't have anything. And as usually with this kind of topic, it's always good to go to the basics. So let's have a look at what data warehouse is. I'm pretty sure that most of you, when I say data warehouse, have some sort of definition in mind, right? Everyone does it a little bit differently. And when you Google around a little bit, you'll find something saying approximately that it's a data management system designed to enable and support business intelligence. There are some definitions that are more strict, longer, more complicated, but in essence, they will all boil down to the same thing. When you think about how these things have been built, and the warehousing as a concept dates to something like 60s or so it's not a new thing, even though Kimball and Inmon are 90s. So if you know their data architectures for warehousing, that's much more recent than the original concept of the thing. But still, it's been around for a while. There are probably millions of warehouses in existence, and they all look more or less the same. Basically, you start with some source data. Typically, when you mean source, it means structured data. So, you have your nice databases, some flat files, and similar things. You load it into another relational database in whatever data structure you need, whether you prefer Kimball or some other layout. And typically, you give access to your business intelligence users or reporting via SQL. You might have tools on this side, or you just have a more technically oriented BI team who are able to go into your warehouse and run the queries directly. But this is what you usually get. Of course, loading the data is never a simple matter, especially if you are dealing with lots of different source systems, and especially in cases where you have multiple instances of the same thing or similar systems that store the same data. You always need to map that to your structure in the warehouse, which often is quite painful exercise and very frequently something that changes as the warehouse evolves and kind of stays with the business for a while. So this is where the things started, right? And as I said, many organizations run the warehouse like this. But the world is changing. We now live in very different place compared to 60s or even 90s, right? The data is now more massive. There's a lot more of it, different kinds of data. And of course, there are a few things that that influence how we think about data, how we use it, and that impacts the warehouses. I've picked 4 areas that have the biggest impact on how you design and use your data warehouses. So I'll discuss this a little bit, and then we'll cover the details about how this impacts the architecture of the warehouse and what you can do about that and how you can solve some of the issues that you encounter there. So the first thing is the cloud, right? This is a huge thing. It's been with us for maybe a decade or even a little bit longer, massively used even in the last few years. And most organizations that we speak with, when they mean data warehouse, they mean warehouse in the cloud. They are not speaking about building some sort of massive on-premise database, but they are talking about like Redshift or Snowflake, BigQuery, and similar cloud-based technologies. In many cases, they need to work with multiple clouds, which tends to complicate matters a little bit. Of course, a huge thing was big data. Now you don't hear big data as a term that often, but many companies embrace that and obviously generate massive amounts of data and use the stack that usually comes with big data like Hadoop and so on. And frequently these leads to having some sort of machine learning, especially in the last 2-3 years. Machine learning is something that we hear all the time when our customers discuss what they want to do with their data once it's loaded somewhere, whether it's a warehouse or data lake or something similar. Of course, we have seen explosion of different kinds of data, right? It used to be that pretty much everything was some sort of a file, sometimes simpler, sometimes more complex, or a database table. But in any case, it was a structured data set. These days, significant amount of data that you will have will not be nicely structured, but will come in some sort of semi-structured format and even unstructured. Right? So I'm sure that most of you have dealt with something like JSON or XML, which is almost the same thing, or formats that are a little bit harder to read, like Avro. And you've seen what data social networks provide, right? You get a wall of text and maybe a little bit of metadata with that. And of course, you can get all kinds of media files like pictures, videos, and all kinds of other things that you might want to process and deal with in some way. And the final thing, that's not about data itself, but rather about how it is used. These days, everything moves a lot faster than it used to. The organizations need to be more agile, and this then, of course, impacts the data teams as well. You need to be able to respond to requirements much faster. The reporting that happens at the end is usually more complex than what you had even a couple of years ago. Right? So all of these things impact how you think about the data warehouse. Let's talk about that a little bit more. So the first thing that I'll cover in more detail is the cloud. This is obviously one thing that impacts how you are even going to build a warehouse. So whether something runs in the cloud or not is something that either you discover because your data sources are in the cloud, right? Most of applications have some sort of SaaS version, whether even by the same provider or someone else provides the same thing as a service. So you will not have access to your data like you used to by, for example, just querying a SQL database or reading some sort of file storage somewhere. You will need to work with APIs, or maybe there's an API to dump the data somewhere or load it in some way. Maybe it has some sort of a webhook or notification service. But in any case, the way of getting to the data is much different. And of course, then you get to the data warehouse itself. As I mentioned at the beginning, most customers that we speak with, when they talk about data warehouse, they mean data warehouse in the cloud. This has obvious benefits, like it's scalable, accessible, always on, and all kinds of other superlatives you'll find when you talk about cloud-enabled services. There are many services that provide warehousing in the cloud. You can start with just a normal database in the cloud and build it there. But oftentimes when we speak with our customers, they mention something like Snowflake, Azure Synapse Analytics, or Redshift, or other similar, let's say, databases that are optimized for warehouse workloads. What's interesting is that as you move your stuff to the cloud, you need to acquire slightly different skills to manage everything there. And you are still talking about databases and so on, but the way you build them is different, the way you manage them is different. So the whole organizations have to retrain themselves a little bit around the cloud first mentality when they try to do something like this. And of course, with cloud being public, usually, right, you can get private cloud, of course, but most of the time it's public cloud, data security tends to be a little bit more challenging. It's just so easy to leave everything at the default and have your warehouse visible. We've all seen over the last couple of years some data leaks when people left either their staging areas like S3 buckets public, or even whole databases with customers. So you need to be very careful. And with not really knowing where the data is, brings more challenges with regards to regulations. You have stuff like GDPR, or even some national laws that require you to process data from that nation's citizens inside their borders and so on, right? That's how Germany has their own data center in Frankfurt, because that's required for some of the data Germans have. So all of this impacts your decision of where the data warehouse will be located. And in this talk, I'll basically speak about the cloud warehouse, right? Of course, many of the things I'll say apply to on-premise warehouse, but I'll focus more on the cloud, since that seems to be the trend where everyone wants to go. Then, of course, we have the data processing trends with changes to how you want to get your data into the warehouse. As I mentioned before, big data is a huge thing. Right? There are many companies who need that, who are using the whole Hadoop ecosystem, whether it's something as simple as just having a huge store of data somewhere in the ADFS, or maybe they are using Spark or even something else from Hadoop to process their data. So, you need to work with that and be able to consume data from there and store it somewhere. Then, of course, you have the machine learning, which requires access to massive data sets, not only for running the models, but also for training. And this brings a whole lot of challenges with itself. Oftentimes, it can be very useful to run it, but it's very challenging to do it properly. Again, if you look at news, oftentimes we see stories about companies using machine learning for something just to figure out that their models are slightly wrong and, for example, misidentify people or assign them wrong categories or something like that, right? So all the time you can get interesting information from machine learning, but on the other hand, you need to be careful about how it's built. And we have the data scientist, which is again something that, at least from my point of view, has not really been here. If you look something like 10 years back or so, of course, the people who are doing data science, many of them have been doing something similar back then, but there wasn't any term for that. But now these days you have a lot of technologies that help you there, and they are slightly different from just a normal data engineer's job. It's not just ETL, but oftentimes you need to know a little bit about statistics, or you end up using all kinds of tools like R that will help you analyze your data. And data science, while very interesting thing, again, is something that can be quite dangerous when not done well, because oftentimes when you look around on the web, on forums where data scientists talk, you'll see that they spend significant amounts of time just wrangling their data, making sure that it fits whatever they need to, reformatting it a little bit, cleaning it, and so on. And to make their work most efficient, you need to make sure that whatever data you keep is usable by them very easily, and they do not have to spend 70 or 80% of their time just reformatting the data to slightly different layout or loading it into a different tool, so just they can use whatever tools they need. I mentioned that the data types or data structures have changed as well. When you look at kind of recent developments, you might think that structured data is kind of going away, but it's not really. A lot of things will remain structured or kind of in the format of it's either flat file or a database, simply because that makes sense. And in many cases, you'll have a lot of enterprise tools, whether it's something like CRM, ERP, and so on. Many of the concepts that I use map very well to flat data with some basic relationships between entities. So this is not going to go away anytime soon. And of course, given the long history of this kind of data, there are a lot of great tools that will help you process the data later, whether a lot of reporting tools support structured data very easily. So it's easy to get some sort of insight out of that. And of course, you have the databases with great performance around processing large amounts of such data and so on. But what's interesting is when you start thinking about how you are building your warehouse is when you get to semi-structured and unstructured data. That is something that doesn't map very well into traditional data warehouse schemas. Oftentimes you'll hit this when you work with different kinds of APIs, which then kind of takes us back to software as a service, right? Because you are no longer able to query the backend database of your application, but you need to use an API, which frequently will be REST API, giving you back some sort of JSON document. Or you might have social data, which is very popular, especially if you are doing anything in marketing, right? You are scanning your Twitter, LinkedIn, Facebook, Instagram, whatever else, right? And then there's a ton of data there. Some of it has simple structure, like Twitter post or tweet. You have username, date, time, location, and a little bit of text, but you might have a picture there or a video, right? And you might want to process that in some way as well. And all of this is much harder to map to the standardized dimensions and facts or just simple tables and foreign keys within them. You can split by entity, but then you might fight with having thousands of different entities, many of them just a little bit weird small entities that don't hold much information. Or maybe you can just employ some more complicated transformation to map it to some more useful concept compared to what the API or the source data provides. but that again can lead to very complicated transformations. So you need to find some sort of balance between what you take out of your data and how you load it into your warehouse. And finally, we have the agility part, meaning that you want to respond to the requirements changing as quickly as possible. This is all very apparent in the last couple of years, where you can see movements like DevOps and DataOps really taking off, and a lot of teams, organizations are jumping on the agile and actually putting a lot of effort into making sure that what they have works very well. So the ideal is that the cycle time between someone acquiring some sort of data and the data being available in whatever format they need it is ideally days, or even hours if possible, although not always. So this is something that will pressure you into building systems that are very easy to use, scale very well, and in many cases even provide some sort of self-service capability, so that end users can query the data they need by themselves without having to go through the whole organization and the whole process of requiring something to be done. Now, with all that talk, let's have a look at what a warehouse might look like. Right? When you take all of that into consideration and try to think about how you would handle something like that, you still have your data on the left side, and we're going left to right. You have different kinds of data. You need to load it in some different way into something. And that something still is your data warehouse, but it's no longer just a simple data warehouse where you have a relational database. Oftentimes, modern warehouses are composed of more than one tool. Usually what we've seen before is that you have some sort of a data lake or large storage area that often is used as a staging, but you also keep the data there. So it's not just the throwaway staging area where you just load data for a little bit before it's loaded into the relational database, but you keep it there, and users or consumers of the data can rely on the data being there in some reasonable format. Then you typically have some sort of ETL process that goes from your data lake, processes the data, applies business rules, cleanses everything, and maps it into whatever schema you have in your warehouse or relational database in the warehouse. And this whole thing is the warehouse, right? So the warehouse is no longer just a simple or single application, let's say, but rather it's a collection of multiple applications. You can, of course, have multiple pieces, right? Your data lake might not be a single location either. It might be something like a Hadoop, but you might have a bunch of things on something like blob storage or in MongoDB, right? All kinds of combinations exist depending on what kind of data you have. In any case, what's important is this bit, that you need to model and serve your data in a certain way. The models and data output from the relational database, that's kind of the old school warehouse where you work with nicely laid out tables, you can do aggregations and all of that, but you also need some sort of model for this stuff, right? You don't want to just throw it there and let it be, and no one will be able to use it. And for sure, when you talk to data scientists, those are the people who will go here, and they will be very unhappy if everything is there, all over the place. It's hard to find, and even harder to figure out what it means. And when you look at consumers, you no longer have just regular BI or reporting users or consumers of the reporting data, but you frequently will have machine learning, which will need to go to both the raw data in the data lake, but also often needs to access the relational database as well. And same for data scientists, except they typically are even more demanding because they do not use just a small subset of data. They can essentially, figure out something cool from anything that's there. So we need to be very careful about building the whole pipeline and making sure it works. And as I mentioned, most of the time when I talk about the warehouse, I will mean the warehouse in the cloud. So this orange part typically is in the cloud. Some parts of this will be in the cloud as well for many organizations. And many of these services, well, except users, will be in the cloud as well. And you can easily get machine learning in the cloud. Data scientists can have their tools in the cloud, so they do not have to download everything to their computers. Now, let's break it down a little bit. let's talk a little bit why data lake and warehouse there, or a traditional relational database. The first thing is that you want your data loaded somewhere, and you want the data load to be as simple as possible, right? That's the ingest part of getting your data from your source systems. The reason why you want to do that is simply to not overload your source. And there are all kinds of technologies that will help you store your raw data very effectively. You can very easily do that with blob storage. You just need to organize it a little bit by yourself, not just throw everything into a single S3 bucket. Right? And again, there are multiple different ways of doing that. You can use a Hadoop file system to store massive amounts of data, which is especially useful if you are using Hadoop for anything, right? It will integrate very well with this kind of storage. Or if large amounts of your data come in form of documents like JSON or something similar, you can use NoSQL databases very effectively. Just put it there and then reformat it to something more useful later. You will still keep the what I call classic warehousing there, so that you can still very easily serve the, let's say, more traditional use cases that work with structured data. That would be your, let's say, financial reporting and or forecasting, or sales reporting and so on. All of those things do not typically need complicated data or machine learning or stuff like that. It's very well doable without all of that. And traditional data warehouse serves very well because it's tried technology. There are, again, very good tools that help you there. And the reporting tools know how to work with warehouses. So they will help you build your reports very easily compared to if you invent something completely new that's unique to you. And of course, again, when we are talking about cloud-based warehouses, there are many databases that are optimized for massive data sets that you can expect in a warehouse. So you can go with Redshift, Snowflake, Azure Synapse Analytics, and others. Right? Depending on which cloud you go for, there is always a tool that is native warehouse database in that cloud. When we look at the next step, so you have your data in the data lake, and you then need to get it into your relational database. This is where the complicated business logic comes in, right? Because your data can be in all kinds of different formats. You need to apply some business rules. You need to make sure that you clean the data before you load it into the warehouse, because if you have even small fraction of broken data in your warehouse, it can break the results, and it will not be trustworthy, and users will try to build shadow IT around it, and that's obviously not something that you want. What's interesting is that this is the place where you decide how frequently you want to load, right? When you ingest data from source systems, you typically want to load it as fast as possible, so you don't have massive data batches that would overload your source, but rather, you load data as it comes in. But in here, you can decide how frequently you want to do that, and that will depend on your use cases. Some companies require near real-time updates, so they will do it all the time. Some companies are fine with updating warehouse once per day. And then again, there are a lot of tools that you can use. We are a vendor of a data integration tools. Obviously, I would recommend Clover DX, but of course, you can use many other tools, but still, Clover is the best. When you look at handling of the source data, which is part of either the data ingest process and then of the transformation from raw data into your warehouse or into traditional part of that warehouse, the first thing that I always mention is the data quality. And this is something that's frequently forgotten because everyone focuses on just how to map the data into whatever structure they need. But the problems start even at the beginning, right? We all know that people can type all kinds of weird things into the computer. So oftentimes you get simply data entry errors or bugs in the applications creating problems and so on. And you need to make sure that this is handled in the ingest stage. Whenever you are loading data from your source or into the data lake, just make sure that you remove low quality data, unless measuring the data quality is one of the use cases you have. Right? You might want to train machine learning to do that or something like that, but always handle it as soon as you can so that you prevent creating something that we call data swamp. And it's not pleasant dealing with something like that where you don't really know how good the data is. When you do the ingest, you want to load your data as simply as possible. So minimal data transformations without complicated mappings or anything like that. So that part of your pipeline can be as simple as possible. Different approaches work for different kinds of data, right? With structured data, you can just dump the files there or even load directly into the warehouse if the data is good enough, right? It really depends on what you're dealing with. With semi-structured data, you can either keep it in the original format, meaning, if it produces XML, you store XML. If it's JSON, you store JSON. Avro, you keep Avro. Or maybe you want to reformat it in something that's common. In that case, you need to find a format that covers everything that you have, right? You can always convert pretty much everything into JSON, but it's not always a good idea. So you need to, again, find balance between just having super simple ingest stream or having something a little bit more complicated, but then maybe more comfortable for people to use in the end. And unstructured data, typically there's not much you want to do with it, right? You just store it somewhere. But what you frequently want to do with it is extract some sort of metadata out of it as you are ingesting. It can be really as simple as author of a blog post or something like that. There is always some metadata associated with it, or date when it was posted, or original name of the file where it came from, and so on. And this is something that can be very useful later, especially if you want to link to that object or media file from somewhere else, right? So you can search for it and so on. A special place is reserved for high velocity data, or something that I would call high velocity. Frequently, we'll be dealing with something like IoT data or some sort of streaming use cases. Even, for example, if you have a large website, you might have clickstream data, that a ton of data that you are getting all the time, right? So this is something that you want to load as fast as possible. And in many cases, the approach that worked very well for us is to use some sort of messaging system as a buffer, right? You have your producer, which produces data more or less randomly. Sometimes it's 5 messages per second, but you might have spikes, thousands of messages per second. And this is not something that you want to deal with in your pipeline later. So you want to dump everything into something simple, either Kafka or some sort of messaging queue, and keep the data there until it's processed. The little lambdas over here, I put them there because you can either use Lambda functions or similar concept from other cloud providers when you are loading data from producer here, or you can use them later to maybe batch it a little bit and load it into data lake, so that you are not loading a single record at a time, but some sort of micro batching, or applying some sort of data validation rules, so you reject data that you for sure do not want, and so on. And always good to have something like that that allows you to filter it down to only the things that you want to use. Because the worst problem is if you keep everything and people will not be able to find the data they need. Right? So kind of overloading everyone with too much data is not very useful either. Very interesting things when you get to machine learning and data science. These are use cases that often behave slightly differently than traditional reporting, because oftentimes either machine learning teams or data scientists will ask you for access to raw data because they want everything, but then they realize that, well, raw data is nice, but it's raw, right? It contains all kinds of things that you might not really want to process in the end. So they spend a lot of time massaging the data into something that they can use. So you need to be careful about what kind of permissions you give them, and you need to make it clear like what kind of data they get, and so on. And this is something that's kind of outside of the scope of just the warehouse technology, but rather is in scope of the processes that you have within organization, making sure that there is documentation, or maybe something like metadata repository or something similar that helps your users find where the data is and what it is. What's interesting about these two use cases is that they frequently are not just consumers of the data, but might produce something. Whether, for example, you get some insight from machine learning, right? It might categorize your users based on pictures they post. And you might want to write that somewhere, maybe into a user table somewhere in your relational part of the warehouse. right? So you might need to give them the ability to update your warehouse, or maybe they build a separate system and you use it as a source. But this is also something that needs to be considered when these use cases are part of your pipeline. One thing that's very important is thinking about how you are going to build the whole thing and how you are going to maintain it, because the warehouse is something that is going to stay with you. It's not something that you want to build and then throw away in a year, or realize that you built it incorrectly and need to rebuild it, and it will take you another 3 years to get there. So you might want to embrace DataOps and DevOps approaches that will force you to basically use agile methodologies to maintain everything that you have, which on one hand also helps you with shortening the cycle between the specification of something and having the data ready. But also when you think about how these approaches work, oftentimes they rely very heavily on automation. Frequently you have everything specified as some sort of code, whether it's the actual code for your business logic or for your reports or for anything, but you also have infrastructure defined as a code. All of that is tracked in version control. And then when you change something, whether it's the infrastructure change or code change, it gets automatically provisioned, tested in your test environment. And depending on how far you want to go, you can even automatically take it into production. And this is something that many companies have embraced. It's not an easy process to get there. But this is how, for example, Amazon did, I think, 3 million releases to production about a year ago or 2 years ago, right? So this is not something that you can do with a traditional process where you start something, manually test, and so on. You need to automate as many steps as possible. And as a result, you can have a warehouse that when you change your source systems will update very quickly, and you will not have to wait a year for someone to finally implement your specification, but rather you push a couple buttons and things start happening, and you will see incremental changes until the whole thing is there. And finally, the last step is kind of thinking about how you want to provide your data to consumers. This is again something where we now have a lot more options compared to even 10 years ago. Oftentimes, as I mentioned, some users will want raw data, but this is not for everyone. Right? Not everyone wants to dig through some sort of Hadoop file store, searching among the hundreds of thousands of files, or looking into some petabyte data set for what they need. And data scientists and machine learning teams, they will be fine with it, especially if the data is nicely laid out and easy to find. But your usual business users do not want to do that, right? They want to get their reports usually regularly or at the push of a button whenever they want. So in this case, one thing is this kind of, just use the tools that are there. Do not try to build your own reporting, just, throwing together thousands of SQL queries and scheduling that in cron. While you'll probably get quite far there, it's not something you want to maintain. Just give the users the ability to see the reports they have, allow them to drill down to whatever data it came from and do it visually. And there are all kinds of tools on the market that can help you there. What is also a big trend is self-service data, which is something that we've seen before. And it can be kind of a two-edged sword. On one hand, it's very useful, right? Your users, in theory, should be able to get to your data, do whatever they want with them. Oftentimes, you'll see something like notebook-style data access, where you might have Jupyter notebooks or Apache Zeppelin or similar, where people are supposed to kind of just type some sort of a query and get data back. But oftentimes, this causes a lot of headaches because many users do not want to deal with this. They'd rather get their Excel table and not have to write or copy paste something somewhere, right? So you need to, again, find a balance between giving users power to do this, but also giving you the users who do not want that the ability to still consume the data without having to learn Python or R or something similar that you can run in those notebook-like applications. All right, so as I mentioned, basically there are a lot of things that have changed, and when you look back at how the warehouses are built, oftentimes you'll see that they are not as uniform as they used to be, right? It's not just a database with some tables, but rather it can be all kinds of tools working together to implement a warehouse, even if it's like a data lake and a relational database, or maybe some sort of a NoSQL store together. So that's basically everything from me. If you have any questions, I hope that you posted them into Q&A box, and I'll give the word back to Tessa.
Brilliant, thank you, Branyo. Yes, we have had some questions come in, so we'll get to those. Bear with me 1 second. Okay, so first one, when handling APIs for data warehouses instead of direct connecting, what capabilities and flexibility is given up?
Okay, this is an interesting question. I'm not sure which part of the warehouse you mean in this case, whether it's loading data from an API into warehouse or providing an API for the warehouse. So I'll try to speak about both a little bit. Hopefully I'll I'll hit what you are asking. So when you are loading from the APIs, one thing that you need to make sure is, that you do this in a way that, for example, doesn't overload the API, especially in the cloud. Most APIs have some sort of rate limitations. So you need to typically load data frequently and oftentimes in like some small batches so that that you get your data into your data lake as soon as you can, right? You do not want to wait too long because otherwise you might not be able to catch up, especially if the thing that you are connecting to changes often. When you want to provide APIs for your warehouse, there are again different things that you can do. Typically, if you provide something like a REST API, there are a few ways of doing that for basically everything. You can, let's imagine that you have a user dimension in your warehouse, right? So there's a table that contains users. You can have an API that gives you a user by ID, right? So you give it an ID and it gives you a single person or maybe multiple people if you provide multiple IDs. But you can also have an API that dumps the whole table into a file and the user is supposed to pick up the file somewhere, or maybe it's a response of the API itself, right? It really depends on what data volume you are dealing with, especially if you expect someone to work with large data volumes, then REST APIs might not be the ideal thing. And so again, that's the balance between providing users the ability to query something through an API, or them or the users deciding to use direct access if they need something larger. So you are not really losing flexibility, at least not as far as I know, but you need to be very careful about thinking through what kind of API you want to provide. And that usually requires you to know a little bit about what your users are going to do with the data.
Okay, great. A few questions about the recording of the webinar and the slides. We will be sending these out after the session, so don't worry about that. Could I also ask, if you have questions, please pop them in the Q&A box, as we don't want to lose them in the chat. But Branyo, next question. What is the difference between a data lake and a data warehouse?
Yeah, okay, this is an interesting one, all right? So let's go back a little bit to this slide. So when I look at this, I have a data lake over here and something that usually would be a data warehouse over here, but I call the whole thing a data warehouse, right? So it's really kind of up to you how you decide to name your things. But usually when you talk about data lake, it's something where you store your raw data. You do not have database tables there or anything like that. It's kind of a landing area. You need to organize it in some way, right? So for example, you create different places in that, maybe different directories if it's something that has a concept of a directory for, I don't know, data from CRM, from data from social network or something like that. But the point is that it stores raw data and the access to that is usually in form of, let's say, files, right? So you are not going to be able to natively run something like select from something. There are tools that do that, right? Of course, for example, in AWS, you can use tools to query S3 data directly. Something similar is possible in Azure. I don't know the name of the technology, right? So it's possible to do that, but usually you are talking about storing files somewhere. That's the data lake. But when you look at the data warehouse, that is something that has very well-defined structure. The structure is defined upfront. So when you are starting to build it, you decide this is a record for a user, it goes into a user table. This is a record for an account, accounts table, and so on. All right. So at the beginning, you decide what it looks like, and you create a schema or multiple database schemas to host your data. So when you want to talk to the warehouse, you use typically SQL. And again, there are many tools that build on top of that allow you to, for example, visually query the data or display it directly without you ever seeing a single SQL statement. Right? But the difference is in the lake, you store unstructured data, while in the warehouse, you store structured data. And workarounds of putting images into blobs in a warehouse, yeah, you can do that, but I probably wouldn't. Yeah, so that's the main difference between those two things.
Great. We've had quite a few questions coming in, so bear with us. Next one, how do you handle normalizing data such as date and times? Pipeline from data source in a data lake, a data warehouse, or in a data viz tool?
That would probably depend on the use case. Frequently in the data lake, you will keep it as it is, but you need to make sure that people know that it's different, right? For example, you have date and time, you might have different time zones, but it might not be apparent from the data itself. It might just say, I don't know, 3 p.m. and which time zone, right? So you might need to keep some extra data or have it documented somewhere so that people querying that data know what they are dealing with. Usually when you go into the warehouse, right, in this ETL process, you want to normalize everything into that kind of rigid structure of the warehouse, right? So your timestamps are normalized to one time zone, and maybe you provide the original timestamp in a separate column so that you can run analytics on top of that as well. The same thing for standardizing names of things, right? It might be lowercase, uppercase, mixed case over here, but in here maybe you convert everything into uppercase so that it's a little bit easier. It's really up to you, but typically this ETL step handles all the data cleansing and normalization, while this data ingest doesn't really do much, maybe some light touch on the data so that it's a little bit easier to store in your data lake compared to whatever format it came in originally, but that's it, right? Typically, you want this to be as simple as possible, while this is the place where you do your business logic, which also means that you might have data lake might be split into multiple places. You might do ETL and then load back into the lake because it's not something that you want in a relational data store, but still you want to keep it.
Brilliant. Okay, do you have any advice for how to handle data sources that unexpectedly change? Perhaps a column added, removed, or JSON structure changes?
Yeah, so this is actually something that's very hard to deal with, and especially I'm pretty sure that this has happened to everyone who used some sort of software as a service, right? The API just changed, and there are new entities there in the response, or something has been renamed. It really depends on how you want to handle that. In many cases, during the ingest, you try to make it work with kind of generic data format. So if something changes, for example, if you have a JSON and it has few more elements in it, then you just dump it into the data lake and deal with it over here in the ETL part. It will be very hard for machine learning teams and data scientist teams to handle that because they will need to special case their stuff, right? For example, this year we don't have the column such and such, but it's there since 2 years ago, right? So it really depends on how you want to do that, but usually in here you try to make it simple and load as is. You just need to make sure that the process can handle that using tools that can deal with such changes. And in ETL, you oftentimes end up with special casing, right? So if the data is from, let's say, year before 2020, assign default value to the column ABCD because it was not there before, and you load it into the warehouse like that. You need some sort of reporting, right? That's important part of loading anything like this, that if your data changes or if something starts crashing because the API has changed or data layout has changed in incompatible way, you need to know about it instead of silently just ignoring something. And then it's just up to the people who manage that to build it.
Okay, what are the prerequisites or requirements to create a good DataOps pipeline when it comes to both techniques and organization?
All right, this is a good question, but it's also a loaded question. We actually had a webinar about this, I think 3 weeks ago or so. But basically, when you think about DataOps, the first thing that you need to get used to is the agile way of working, right? If you are used to kind of top-down development methodology where someone gives you specifications, sends a document to a different team that translates it into something and so on, that usually doesn't work very well. You need to make sure that your people understand the agile way of working and know that when they are supposed to deliver something, they need to split it into small pieces that can be delivered quickly so that you can see some progress, right? That's why you have stuff like sprints in the agile methodologies where you deliver something like every 2 weeks, for example. So, you don't get the whole report immediately, but you get pieces of it and it improves. And in like 2 months, you might have the whole thing if it's something really complicated. Right? But probably the hardest thing for many organizations to change is kind of the agile way of thinking about problems and about solving them. And on the technology side, it's the automation of everything, making sure that everything is in version control, that you can use continuous integration to deploy, to test, if possible, that you have infrastructure defined as a code, right? Not always possible, but you might want to get there, right? So that would be the technical side of it.
Okay, thank you. In case of only structured data, is there any advantage in a data lake and data warehouse architecture versus only a data warehouse?
Yes, depends on how you would use it, but I would say that whenever you are loading something into warehouse, you still want to keep some sort of staging area, right? You never want to go directly from your source into the finished warehouse, right? You always want to load into stage in whatever format is the original, even if it's a structured data, right? So you have tables that look for sure differently than what they look like in the warehouse. So you load into your data lake. That in this case, if it's structured data, it's not going to be data lake as such where you would have it in S3 bucket or something like that. You might have a relational database as well, but you will load raw data there and then apply your business logic over here. And the benefit there is that, again, this load can be very simple, making sure that you don't overload your source database or whatever source system serves your data, and you can go back because you have the data in original format over here. You apply your business logic, it might change it substantially, right? You might have, you might map numbers to category names or something like that, or completely change the layouts of some entities as they go into the warehouse. And you might decide to change this, and it might be very hard to reapply the same changes if it's already changed over here. But going back from here, you just reload, right? So this is something where you would keep your data in the original format, and if you change this process significantly, you can reload whatever you have in the warehouse.
Okay, what tools or techniques could we use to secure data quality in the data lake or data warehouse level?
That is something that basically we'll have to monitor your data as it comes in, and you decide whether you want to reject something in the ingest pipeline or not. And usually you want to ingest data that is completely broken and unusable and keep that something that's at least reasonable. And typically this will be part of your ingest pipeline. If you use something like Clover DX for your data ingest, there are all kinds of components that you can use, or all kinds of tools that you can use to measure your data quality, reject data. Same here, right? Every ETL tool will have the ability to work with your data quality in some way. And it's then up to you to decide what you do with the broken data, whether you send it, for example, for manual review somewhere, or you notify the source application to fix their stuff. And it's really up to you, but usually you deal with that in the ingest step, typically on kind of high level. And in the ETL, you do it in more detailed level because you need to make sure that whatever gets here is clean and needs to be relied on, can be relied on, because this is frequently kind of a single source of truth for all the data that you have, right? Every part of your organization might go here and query some sort of data from there.
Thanks, Vanya. Okay, do you have a comparison related service on top of cloud providers such as AWS, Azure, and GCP, or OpenStack for private cloud, or third-party vendors on Marketplace?
Okay, the way I understood the question is you are asking basically if we can give you some advice that will help you decide which cloud provider to use. We can, but we are not that kind of a company. We are a software company, but if you have any questions, let us know by email or talk to us, especially if you are looking for how to build that and how to get the infrastructure in place to building a warehouse. Then we will work with you, and if you are not sure which cloud provider to pick, we can help you there as well.
Thanks. Okay, any suggestions for using multiple databases? So some SQL, some NoSQL, some graph databases for creating reports. Should we expect to have multiple databases, or could we merge into one massive database?
You can do it both ways. Some customers do not want to deal with such different technologies, so they will, for example, decompose data from graph database into triples of, and load it into some tables or more complex entities. The same for NoSQL, right? Usually you can decompose it in some way into flat data, but in many cases, keeping the let's say graph database can be very useful, right? It's different way of querying that, but the data that it stores, the extra information that you have in the relationships between entities might be very useful. And if you just translate that into a SQL database or into a flat database, then those queries might be significantly more complex. So it really depends on what is your end use case. You can do both, and there are organizations that keep different kinds of databases and use them for different purposes. But there are also organizations that reformat everything into single relational database that's a little bit larger, but usually not an issue, especially if you are in the cloud.
Okay, thanks. So this is relating to one of the previous questions. When changes in incoming data require schema changes, what is the best way to deal with the schema versioning?
That would depend on what technology you are using. So you might use tools that allow you to keep track of that, some sort of data catalog or something like that will help you track changes in your data layouts. Or you might decide to convert your database in the end, right? So if you need to change it, you apply transformations in such a way that the historical data that doesn't conform to the new schema is made to conform, right? Basically, you transform it so that it maps properly. It's really up to you. This is also the reason why you want to keep everything in version control, because the schema for the database, right, it's usually a bunch of SQL scripts. Those can be very easily version controlled. So if you keep only one warehouse and do not have multiple different versions of it, saved somewhere, then you at least can look back into your history and see what changes have been made, and ideally even why, because there will be some documentation around.
Okay, so I'm conscious of the time, so we'll move through these final ones. Do you have recommendations for when and how to use schemas for the raw data in your data lake?
That's an interesting question. Again, it would really depend on what you want out of your data lake. Typically, my recommendation is if you can describe something in a schema, whether it's a schema for something like a database or XSD or something similar, just put it there and make sure that whatever files or whatever data you have there conforms to the schema. It just makes life easier for the consumer, because they do not have to go somewhere hoping that your data is something, right? This is kind of a curse of REST APIs. On one hand, you do not have to hold any schema really, because JSON is just a JSON, right? I've seen very little of JSON schema or something similar, but it's there. And if it's there, it can help you a lot when you are trying to navigate something and and understand whether some sort of response you get is good or bad, or if it's a bug or not, right? So if you have schema for something, make sure that the files or that the data matches the schema, and it will help consumers. But it's really up to you whether your use cases can take advantage of that or not.
Thanks. Okay, so this one, looking into your crystal ball, what do you think will be added to this presentation in the next year or two, Brania?
Okay, this is an interesting question. I think that as more companies start building bigger and bigger things, right? Basically, people started hoarding data. The storage is very cheap these days. You can store so much data that you don't know what to do with it, and you can store it for almost infinite amount of time, right? So companies will amass huge amounts of data, and the pipelines that happen here between the data lake and the data warehouse need to handle that. So the technologies that do this part evolve a lot, and the machine learning is becoming part of that. So I think that what's going to happen is that people will try to apply that to automate the whole process of kind of creating the warehouse, right? So instead of having a bunch of analysts sit down and look at whatever your data sources are, you let the tools to figure it out. I don't know what the shape it will take, whether there will be a step over here or something, it's not going to be called data lake, but something different or will happen there. But I think that's going to happen, because we've had that question before. What do you do when your data layout changes? How you handle that? It's often difficult. But if you have tools that do that for you and that somehow make sense of the data, even if you don't explicitly tell it what data it is, then I think that's going to be a big change. But I don't know what shape it will take, whether it will be just a different way of doing the warehouses or completely new terminology for that.
Okay, great. One final question in, because we're going to wrap up at the top of the hour. So any tips of literature or other information about DataOps?
Oh, sure. Watch our webinar from a couple of weeks ago. I don't remember the date, but I think I did it like 3 weeks ago or so. So I talk about DataOps there in a little bit more detail. And I would say, Google is your friend. Just search around. I don't have any books at the top of my head, but there's something called DataOps Manifesto. And if you search for that, it outlines the basic steps. And if you kind of start searching for the terms that are mentioned there, you'll find a lot of good information online.
Okay, brilliant. We've had loads of comments in the chat, so thank you to everyone for keeping it alive. It's been a great session. So just a quick one before you all go. We've got another webinar that's coming up, and that's next week, Tuesday, December the 1st. And this one's going to be on starting your modern data ops journey. So this one, we're going to explore data ops, what it is, why you should consider it, and how to begin your transition to a DevOps and data ops style of work. So I've popped the link for that one in the chat right now, so you can go ahead and register for it. And we've also got a live product demo coming up tomorrow. We host these every Wednesday, so you can come along, see Clover in a little bit more detail, and it's very much an interactive session, so you can ask any questions. So pop the link for that one in the chat too. And I guess we're at the top of the hour. So thank you all for attending. Thanks for keeping the chat alive. It's been great. And thank you, Brania, so much. We hope to see you either tomorrow or next week.
Thank you, everyone.
Thank you.
Have a great day.
Bye-bye.
Goodbye.